so that we can accommodate about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence. Well, the reason why money is smart is because we use a lot of documentation. So very clear. It's very clear that it's hard to tell. You don't want to reach your hand into a dark place. It's a good idea. Wait for it. Wait for it. I thought I was worthy. All right. This is my show and tell. This is a show and tell. So this MD-Link system, this right here is that MD-Link system. This is GB200 MD-Link 72. It is 1.5 tons, 600,000 parts, approximately equal to 20 cars, 120 kilowatts. It has a spine behind it that connects all of these GPU together. 2 miles of copper cable, 5,000 cables. This is being manufactured in 45 factories around the world. We built them, we liquid cool them, we test them, so we disassemble them, ship them parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them. The manufacturing is insane. But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, which are phones in the future. Just all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by systems. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that can be generated, the amount of business that can be generated per data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now, the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we would have had to build a chip, here it goes. Sorry, guys. See that? That's cool. Look at that. This still lights in here. If we had to build this as one chip, obviously this would be the size of the wafer. But this doesn't mean active yield. It would have to be probably 3 or 4 times the size. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips. Okay, and we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the black bells. These are our ConnectX networking chips. These are the NVLink. We're trying to pretend about the NVLink spine. That's not possible. And these are all of the HBM memories. 14 terabytes of HBM memory. This is what we're trying to do. And this is the miracle. This is the miracle of the black belt system. The black belt dies right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to that, this is the grace of black belt system. Well, the goal of all of this, of course, is so that we can. Boy, is there a chair I can sit down for a second? How is it possible? Michelob Ultra Stadium. It's like coming to NVIDIA and we don't have a GPU for you. So we need an enormous amount of computation because we want to train larger and larger models. And these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's basically as fast as anybody can read. However, in the future, and right now with GPT-01, you know, with the new the Gemini Pro and the new the 01, 03 models, they're talking to themselves, reflecting. And so, as you can imagine, the rate at which the tokens can be ingested is incredibly high. And so we need the token rates, the token generation rates to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, cost to customers can continue to be low, and AI will continue to scale. So that's the fundamental purpose, reason why it can be like. Well, one of the most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. It's AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools, it might be using a calculator, and it might be using a generative AI to generate charts and stuff. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all those different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build agentic AI, our go-to-market is not to our go-to-market is we work with software developers in the IT ecosystem to integrate our technology to possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are doing computer graphics, or doing linear algebra, or doing dynamics, in the future, on top of those acceleration libraries, we'll have AI libraries. We've created three things for helping the ecosystem build into the AIs. NVIDIA NIMs which are essentially AI microservices all packaged up. It takes all of this really complicated CUDA software, CUDA DNN, Cutlass, TensorRT-LM, Triton, all of these different really complicated software and the model itself. We package it up, we optimize it, we put it into a container, and you can take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models for physical AI. And these AI models run in every single cloud because NVIDIA's GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or they might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customer wants to run it. The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, working along, doing things for you on your behalf. And so the way that you would bring specialized agents into your special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company, and the vocabulary is unique to your company, the business process is different, the way you work is different. You would give them examples of what the work product should look like, and they would try to generate it. You would give them feedback, then you would evaluate it, so on and so forth. So that a new guardrail. So these are the things that you're not allowed to do. These are things you're not allowed to say. And we even give them access to certain information. And so that entire pipeline, a digital employee pipeline, is called NeMo. In a lot of ways, the IT department of every company is going to be the HR department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies you use. Okay, and so your IT department is going to become kind of like an AI agent HR. And on top of that, we provide a whole bunch of blueprints that are ecosystem with take advantage of. All of this is totally open source, and so you can take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of the NVIDIA Llama Nemotron language foundation models. Llama 3.1 is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that, that has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tuned using our expertise and our capabilities, and we turned them into the Llama Nemotron suite of open models. They're small ones that interact in very fast response time, extremely small. They're super, what we call super Llama Nemotron super. They're basically mainstream intelligence of your models, or your ultra model. Ultra model can be used to be a teacher model for a whole bunch of other models. It can be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not. You have to basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's a number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval, So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. We're also working with the ecosystem. All of our NVIDIA AI technologies are integrated into the IT industry. We have great partners and really great work being done at ServiceNow, at SAP, at Siemens for industrial AI. Cadence is doing great work, and Nas is doing great work. I'm really proud of the work that we do with Perplexity. As you know, they've revolutionized search. They have really fantastic stuff. Codium, every software engineer in the world. This is going to be the next giant AI application, next giant AI service area is software code. 30 million software engineers around the world. Everybody is going to have a software assistant helping them code. If not, obviously you're just going to be way less productive, way less of the code. So this is 30 million. There's a billion knowledge workers in the world. It is very, very clear. AI agents is probably the next robotics industry and likely to be a multi-trillion dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agencies. AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a U-Net regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at NVIDIA, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And video analytics AI agents built on an NVIDIA Metropolis blueprint, including NVIDIA Cosmos Nematron vision language models, Llama Nematron LLMs, and NeMo Retriever. Agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, they monitor processes and generate recommendations for improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here for every organization. Okay. That was the first pitch of baseball. That was not generated. I just felt that none of you were impressed. Okay, so AI was created in the cloud and for the cloud. As created in the cloud and for the cloud. And for enjoying AI and for phones, of course, it's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those meta glasses, you can point at something, look at something, ask it, whatever information you want. And so AI is perfect in the cloud. It was created in clouds. However, we would love to be able to take that AI everywhere. I mentioned already that you could take NVIDIA AI to any cloud, and you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. And so as you know, Windows 95 revolutionized the computer industry. They made possible this new suite of multimedia services and changed the way that applications is created forever. Windows 95, this model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like to have in the future your AI basically be AI assistant. And instead of just the 3D APIs and the sound APIs and video APIs, you would have generative APIs. Generative APIs for 3D and generative APIs for language and generative AI for sound and so on and so forth. And we need a system that makes that possible while leveraging the massive investment that's in the cloud. There's no way that the world can create yet another way of programming the AI models. It's just not going to happen. And so if we can figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is two operating systems within one. It works perfectly. It's developed for developers. It's developed so that you can access the bare metal. WSL2 has been optimized for cloud-native applications. It's optimized, very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with NVIDIA VIMs, NVIDIA NeMo, the blueprints that we developed that are going to be up at ai.nvidia.com, so long as the computer fits it, so long as you can fit that model, you're going to have many models that can fit it, whether it's vision models or language models or speech models or these animation, digital human models, all kinds of different types of models that would be perfect for your PC, and it would should just fine. And so our focus is to turn Windows WSL2, Windows PC into a targeted first-class platform that we will support, maintain for as long as we shall live. And so this is an incredible thing for engineers and developers. Let me show you something that we can do with that. This is one of the examples of the blueprint we just made. Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets created by hand or generated with AI, then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change the camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and NVIDIA NIM, an artist can quickly realize their vision. NVIDIA AI created PC. Hundreds of millions of PCs in the world with Windows, and so we could get them ready for AI. OEMs, all the PC OEMs, which is basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. So AI PCs are coming from a long near view. The next is good. Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and then it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, it has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, every single layer of the transformer, and it produces one token. That's the reason why we need a black hole. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective. Computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of a prompt, a question, it's a request? Go over there and pick up that, that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world, has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. You drop something that falls to the ground, poke out, it tips over. And has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball can lead into another quantum universe that's still there. And so all of these types of understanding, intuitive understanding that we know that most models today have a very hard time with. So we would like to create a world, we need a world foundation model. Today, we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play. The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI. Video Cosmos. Video Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And from this, with this physical AI, there are many downstream things that we could do as a result. We can do synthetic data generation to train models. We could distill it and turn it into effectively to see the beginnings of a robotics model. You can have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that caption and the video could be used to train large language models, multi-modality large language models. And so you can use this technology to use this foundation model to train robots as well as large language. And so this is the NVIDIA Cosmos. The platform has an autoregressive model for real-time applications, has a diffusion model for a very high quality image generation. It's incredible tokenizer, basically learning the vocabulary of the real world, and a data pipeline. So that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end to end for you. So this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of our Cosmos platform. And today we're announcing that Cosmos is open license. It's open available on GitHub. We hope that this moment, and there's a small for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos moral foundation model being open, we really hope will do for the world of robotics and industrial AI what Model 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse. And the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principal physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG or retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application and the use cases are really quite exciting. And of course, for robotics, for industrial applications, it is very, very clear. This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. A robotic system could be a factory, a robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the PGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in a robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its dedicated generation, reinforcement learning, AI feedback, such and such. So it's this digital twin of these three computers going to be working interactively. NVIDIA's strategy for the industrial world, we've been talking about this for some time, is this three-computer system. Instead of a three-body problem, it's a three-computer solution. So it's the NVIDIA provides. So let me give you three examples. All right. So the first example is how we apply all of this to industrial visualization. There are millions of factories, hundreds of thousands of warehouses. That's basically is the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation, and all of it will be infused with robotics. But we're partnering with Keon, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have. Through the developers and ecosystem partners, we have just a growing number of ecosystem partners connecting to the Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of increased GDP. So let's take a look at that. This one example that we're doing with Keon and Accenture. Keon, the supply chain solution company, Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Keon is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Keon's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized to Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Keon can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Keon and Accenture are reinventing industrial autonomy. That's incredible. Everything is in simulation. Every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios is most optimal for whatever KPIs, and that becomes the programming constraints, the programming, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so many years with Waymo's success And Tesla's success, it is very, very clear, autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers, training systems, training AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three computers. We're working with just about every major car company around the world. Waymo and Zoox, Tesla, of course, in their data center, BYD, the largest EV company in the world, JLR has got a really cool car coming, Mercedes, there's a fleet of cars coming with NVIDIA starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and NVIDIA are going to partner together to create their next generation EVs. Just so many cool companies, Lucid and Rivian and Xiaomi, and of course, Volvo, just so many different companies. Wabi is building self-driving trucks. Aurora, we announced this week also that Aurora is going to use NVIDIA to build self-driving trucks. Autonomous, 100 million cars built each year, 1 billion cars, vehicles on the road all over the world, 1 million miles that are driven around the world each year. That's all going to be either highly autonomous or fully autonomous. So this is going to be a very, very, very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. This business becomes, you've noticed in just a few of these cars that are starting to ramp into the world, our business is already $4 billion this year, probably on a run rate of about $5 billion. So really significant business already. This is going very well. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car is called Thor. I have one right here. Okay, this is Thor. And so this is a robotics computer. This is a robotics computer that takes sensors and just madness amount of sensor information, processing umpteen cameras, high resolution, radars, lidars. They're all coming into this chip, and this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AD computer is now in full production. Thor is 20 times the processing capability of our last generation Warren, which is really the standard of autonomous vehicles today. So this is just really quite the problem. Thor is in full production. This robotics processor, by the way, also goes into a full robot. So it could be an AMR, it could be a humanoid robot, it could be the brain, it could be a manipulator. This processor faces universal robotics computing. The second part of our drive system that I'm incredibly proud of is the dedication to safety. DriveOS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles, the only and the highest. And so I'm really, really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. So if you're building a robot, NVIDIA CUDA, yeah. Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And today, instead of showing you a whole bunch of videos of cars driving on the road, I'll show you some of that too. But I want to show you how we use the car to reconstruct visual twins automatically using AI and use that capability to train future AI models. The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers. NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim to real gap. And with text prompts, generate near infinite variations of the driving scenario. With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. NVIDIA's AI Data Factory scales hundreds of drives into billions of effective models, setting the standard for safe and advanced autonomous driving. We take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous. We still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability, so that we generate data for training AIs that are physically grounded and accurate or plausible, so that we can have an enormous data training. The AV industry is here. This is an incredibly exciting time. Super excited about the next several years. I think you can see, just as was at such incredible pace, you're going to see the pace of AV development increasing significantly. I think the next part is robotics. So you know robotics and friends. The ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I'm talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brown field adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we built for ourselves. These three robots are, one, agentic robots and agentic AI, because they're information workers, so long as they can accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. The reason for that is we spent $100+ plus years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology the world's ever seen. And so we think that the right era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to play. And the reason for that is that in the case of cars, we're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and omniverse to synthetically generate millions of synthetically generated emotions. And from those emotions, the AI learn how to perform a task. Let me show you how that's done. Developers around the world are building the next wave of physical AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with four things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos for domain randomization and 3D upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos multiverse simulation engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac GR00T. We're going to have mountains of data to train robots with. NVIDIA Isaac GR00T. NVIDIA Isaac GR00T. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. And well, I have one more thing that I want to show you. None of this would be possible if not for this incredible project that we started about a decade ago. Inside the company was called Project Digits, deep learning GPU intelligence training system. Digits. Well, before we launched it, I shrunk it to DGX and harmonized it with RTX, AGX, OVX, all of the other X's that we have in the company. And it really revolutionized. DGX1 really revolutionized. Where's DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, Ilya Sutskever was there, many of the NVIDIA engineers were there, and we celebrated the arrival of DGX-1, and obviously it revolutionized artificial intelligence computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. You know, we want artificial intelligence, as I mentioned at the beginning of our talk. This is now the new way of doing computing. This is a new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX-1 was smaller. And you know, you know, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless, you know, connected to your computer. It's even a workstation if you like it to be. And you can access it. You can reach it like a cloud supercomputer. And NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Gracie Blackwell that we make. And I have, well, you know what? Let's show everybody inside. This is so cute. And this is the chip that's inside. It is in production. This top secret chip, we did in collaboration. The CPU, the Gray CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU, this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. So it's coming at you. It's just incredible what we can do, and it's just, I think it's really. I'm trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those? And if you use PC, Mac, you know, anything, because you know it's a cloud platform, it's a cloud computing platform that sits on your desk. You can also use it as a Linux workstation if you like. If you would like to have double digits, what would say? And you connect it together with ConnectX, and it has nickel, GPU direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits.
And bring them together.
Okay. Well, let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, the D-Link 72s in production all over the world. We now have the 3 new Blackwell systems in production. One amazing AI world foundation model, the world's first physical AI foundation model is open, available to activate the world's industries, robotics and such, and three robots working on agentic AI, humanoid robots, self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made a short video to reflect on last year and look forward to the next year. Thank you. Have a great CES, everybody.
Yeah. Woo.
How can you